In engineering mechanics, finding out the resultant of any given force system is the first step that we want to go ahead. So let us see what is the resultant force. By definition, we can see here, when a number of forces are acting on a body, it is possible to find a single force which we can produce the same effect as that produced by a given forces acting together. So this can be understood by a simple example here, and such a single force is called as resultant force or resultant. If you see here, O can be assumed as a point or a particle, the position of a particle or a body which is existing in space. And on this, so there are number of forces which are acting on the body here. So I am now taking three forces which are acting on the body. If you see here, due to the effect of the combined effect of these three forces, the body cannot move either in the direction of F1 or F2 or F3. It will move in some other direction here. That some other direction is nothing but the direction of the resultant force. So that means R is nothing but the resultant of these three forces, F1, F2 and F3 taken together. So that means whenever you have any given force system acting on a body, that force system can be replaced by one single force, and that single force is called as resultant force, and the body will move in the direction of the resultant. So in mechanics, our job is to find out the resultant of any given force system. Finding out the resultant means finding out the magnitude of the resultant as well as its direction. But when it comes to the given forces, the directions and magnitudes of the forces will be given. Here I have taken three forces only. It can be any number of forces. And if you see here, R is called as the resultant of the given forces F1, F2 and F3. The process of determining the resultant of a given force system is known as composition of forces. The resultant of a given force system can be determined by graphical and analytical methods. So graphical methods needs drawing instruments, drawing sheets and all, but which we can't practice. But we will follow the analytical methods which are possible in our class here. In analytical methods, two different principles, namely parallelogram law of forces and method of resolutions of forces, can be adopted. So if you see here, what is this parallelogram law of forces, which is already familiar to you. Just as a rehearsal, if you see here, I have taken two forces, F1 and F2 only, two forces, and I can get the resultant of only these two forces by applying parallelogram law. But if I have more than two forces, parallelogram law is not applicable. I have to resort to another method which is called as method of resolution. So first let us look into parallelogram law of forces, which is familiar to you. So the statement goes like this. So this law is applicable to determine the resultant of only two coplanar concurrent forces only. And the statement is, if two forces acting at a point are represented both in magnitude and direction by two adjacent sides of parallelogram, then the resultant of two forces is represented both in magnitude and direction by the diagonal of the parallelogram passing through the same point. So I am taking one particle or body which is represented at the point O. Say F1 is one force which is acting on the body, and F2 is another force which is acting on the other body. Now these two forces, they can be combined into one single force, or we can find out the resultant of F1 and F2 only, because I have only two forces by applying parallelogram law. That means these two forces should be represented as the adjacent sides of a parallelogram. So that, and we also need to know the angle between these two forces, which I call it as theta here. Now I will call OA as the force F1 represented both in magnitude and direction, and F2 represented by OB both in magnitude and direction. So now to construct a parallelogram, I am drawing one line parallel to the line OA through B, and similarly another line parallel to OB through the point A, so that I have a parallelogram OACB. So in which, as we see, the diagonal OC will represent the resultant of F1 and F2. So R is the resultant of F1 and F2. So we can get the magnitude and direction by Pythagoras theorem here. and alpha represents the angle made by the resultant with one of the forces, which is nothing but F1. So determining magnitude means I have to find out R and alpha. So for which, as we said, we have to follow parallel Pythagoras theorem. So how to get a right angle triangle to apply parallel Pythagoras theorem? I have extended the line through A horizontally and drawn a vertical line through C, so that here I have a right angle triangle ACD as well as a right angle triangle OCD. So in the triangle OCD, my resultant is representing the hypotenuse, and how to get the resultant, but we already know OA is nothing but F1. And if we follow the geometry and trigonometry here, this is a right angle triangle 90 degrees. So this is the side, so AC is again F2, so that, and this angle is again theta, corresponding angles, so that the sides AD and CD are nothing but F2 cos theta and F2 sin theta from this right angle triangle. Now looking at this right angle triangle OCD, if you see here, we have, what do we have? Again, as all this has been explained. So the diagonal OC of the parabol will result in both in magnitude and direction. So from the figure, we have again OC square is nothing but OD square plus CD square, but OD is, or OC is under root OD square plus CD square, but OD is nothing but the sum of OA plus AD, but OA is represented as F1 and AD is represented as F2 cos theta and CD is represented as F2 sin theta. Substituting all these and further simplifications, so opening up the bracket here, so these are the, so there are some like terms which can be added here. So we have F2 cos square theta plus F2 sin square theta. On addition we get F2 square here, so that on simplification again here we see that algebraic simplifications will lead to this final one. Here is it now. So this is the equation for the resultant, and also we need the angle alpha made by the resultant with the direction of F1. So if you follow this again right angle triangle OCD, alpha or tan alpha is nothing but F2 sin theta divided by F1 plus F2 cos theta, ratio of opposite side by adjacent side, so that I have tan alpha, or alpha is nothing but tan inverse of this. So this equation 1 gives me the magnitude of the resultant and equation 2 gives me the direction of the resultant.